conference. Now you have fifth plenary session in mode, in mixed mode. It's my pleasure to invite our plenary speaker for their presentation. Thank you very much for your join to our conference. And I would like to say a few words about our plenary speakers. Professor Petra Haferkorn is professor at the Computer Science Department, Bonn-Rhein-Sieg University of Applied Science, Germany. Professor Petra Haferkorn has huge experience in industry, in banking domain. She is supervisor of the direction of IT security management and author of more than 100 publications. The main research fields of Professor Petra Haferkorn are information security management, IT governance, IT risk management, IT audit of companies, public authorities, and other organizations. Thank you very much, Petra, for your participation, and thank you very much, especially for your flag, German and Ukrainian flag, which you have. Thank you. The co-speaker of this our session is Professor Maria Dorosh. Thank you very much, Maria, for your participation in this conference. Professor Maria Dorosh is professor at the Department of Information Technology and Software Engineering, Chernihiv Polytechnic National University, Ukraine. She is Doctor of Science on Project Management Systems, author of more than 110 publications. The areas of scientific activity are research on the convergence and integration of control systems in various applied fields. Co-supervisor of the project models and methods for assessing the convergence of specialist completeness system using AI technology, models and methods for protecting the system from attacks using AI technology. It's my pleasure to invite you for your presentation, and sorry for some delay. Welcome to the third conference. You can share a monitor for.
Thank you. I will share.
Yeah, thank you.
Okay.
Yeah, good morning, everyone. Thank you very much, dear colleagues, for this invitation, and thank you very much for spending your fourth Sunday in Advent at our presentation. I'm grateful for this cultural exchange because I made a huge step forward in my cultural knowledge, because I didn't know that not everybody has Christmas on the 25th and 26th of December, so which explains this date to me. So my colleague Marsha last year proposed to put together the challenges of risk modeling, and as our construction of the so-called reality is done by social systems theory, the social systems theory, which is mainly developed by Niklas Luhmann. We structured our article according to our application of social systems theory on information security systems. So the structure and the headlines are those that we developed from social systems theory. So you certainly want to know who we are. Vyacheslav already presented this. I'm not for a very long time a professor. I only, because I was an auditor for the German Ministry of Finance, I audited for about 20-25 years risk models in banks and insurance companies. And I have to say, after my studies of mathematics and statistics, I found out that this was often the easiest part. It was much more difficult to get enough and to get correct data, to get the data into the model, data from all over the world into the model. And it was very difficult to change organizational routines. The most difficult part is to construct risk models so that these results are used in the companies, so that stakeholders, that they are useful in the facts, but also that stakeholders really hear them and believe in them for their businesses. So this means a lot of communication. Therefore, I made my PhD in sociology. So, Masha, please.
Thank you very much, Vyacheslav Sergeyevich, for your presentation of us, and thank you, Petra, for starting our speech and our speech. And I, as was said, that I'm a professor in the university, Chernihiv Polytechnical National University, and also I have this 10 plus years of IT project management experience, and it gives me a lot of practical things that we need to discuss in this theoretical dimension. So that's why, yes, as Petra said, I asked her about social aspects in information security systems and how can it be implemented and how can it be improved in our very difficult environment with all of these AI systems and etc. So. As project manager, I could have this experience that risk management in information technologies projects are always more about issues than less risks. So I did these risk cards with risk evaluation, and mostly it was ignored by customer while something happened. And then I could show my risk scenarios, results, and say, I told you. And I think that they didn't hurt me because there was a risk description from my PM's perspectives, and for customers, for example, it could sound just like give me some money. For example, I can go and ask, we need a certified cybersecurity specialist to get the contract with a data provider for the project. And I understand that from the customer's perspective, it sounds like I need more money for the project, and he can probably think that I don't want to spend more money for this position. Maybe it can be resolved somehow by PM and project teams. Because it works now. I don't see a risk here because situation can be changed next time. So we had different perspectives, and the customer knows that the project seeks self-preservation. So he knows that we need to decide to leave, to continue the project. We need to decide, and sometimes he can just think that. Okay, you want to survive, your team want to survive, so please make a decision about it. And so we see a very small example of a problem, of a risk situation. But when we are talking about more complex things, more complex decision, this decision about risk, information security, the situation is getting more even more complicated. Because in information security, when we start to evaluate the risks in a project or in other economical organizational systems, we try to have more information. A huge amount of information about the situation, about the scenarios, and try to count everything, and etc. But we have the complexity more complex when we have this new form of communication because of cat and mouse game between attacker and defender. This situation this situation is about they try to hide as much as possible information, and we need to learn. We need to predict. We need to predict something that we cannot know and must be hidden very good. So this is the first reason, and the other reason that if we look at the last researchers and the last articles with risk evaluation models, the researchers mostly want to include a lot of factors, as much factors and as much data in the model, and technical risks, individual behavior of a person, and organization risks, and we see that finally we can see a huge model. Which have 145, for example, 145 inputs, but in a simple situation and in an obvious situation, we have, or we can know about just about 20, for example, 20 factors, and other factors the system can dream or can add for can add for its how it was learning using not our data. Yes, there is a system now that allows to provide the flexibility of this system to put the data, our data, in LLM, but it still doesn't understandable how can we put this social interaction, how can we put this complexity, how can we put this the dynamics of the system in these models, and we don't want to say that risk modeling doesn't mean anything for organization, or it is not useful or something like this. We just want to say that what should we add to the risk modeling process to make it useful and to make more useful this the results of the modeling. In this our research, we have a very good article from Sevellini and Esposito, and they make some assumptions from social system that we need to know and how to include it in, we need to think how can we include it to risk assessment process. So this model says that algorithmic prediction can freeze the organization decision on the previous templates and information security level. For example, as I told, for our example, it can be we don't need cybersecurity specialist with the certificate in the project, because in the past we always worked without certification programs and etc. So it worked well. So why should I change my system? Why should I do something? And the next one is raises an enforceability problem. We cannot prove that it will happen. We have just our illusions about future. So we don't usually have the statistic about risk model execution. So was it effective or no? And what is the deviations of our planning and factors that we have? For our example, it can be as a question, a simple question: why do you think that we cannot continue without specialists? We can have another partner without this certification specialist. I mean, we can have another partner for data providing. We can also lose this project tomorrow, and I don't need this specialist at all, and etc. So another assumption is that algorithmic predictions can involve a preemptive intervention problem, where decisions or interventions render it impossible to determine whether the prediction would have some truth. Yes, we can pay for information security specialist learning, but then I will know what would happen if not. The project is closed that time, another partner, but I already spent my money. So what is the effectiveness of your prediction? You just make me to spend more money, and that's all. And the fourth reason of algorithmic assumption of algorithmic predictions, they say that it can lead to a self-fulfilling prophecy problem. For example, if project management has the money to teach IT, to pay for information security specialist certification program, I am as PM, I will plan another project with knowing that I have this specialist. It can be good, but it can be worse, because I will choose directly the projects with this need. So I start to moderate my future from this point, from this my decision that I made now. So I like this very much from these assumptions, because I think that yes, we are modeling future from the perspective of decisions that we make at the moment. And then we need to understand, if we want to learn and to research this complexity, to understand this complexity, to understand how can we manage it, or even learn it. We need to understand what is concept of risk in a social systems theory. So the first one is the concept of risk refers to possibility of future damages occurring as a consequence of decision made in present, as I told you now, and decision about information security specialists now change the future. Change by the way, change unacceptable ways. So we made decision, and you can understand all the complexity. So decisions. They have these points and put our system to another unpredictable, in a much mostly in unpredictable way. So the next Y is the role of observers. Observers attribute potential future losses to organization decision taken in a particular moment, and also for different observers. So, for example, for our example, we can say that for our customer, he can say that I don't have the certification, IT specialist. If I don't have the certificated information security specialist, I will lose the contract in 100,000 euro. I can count it, but from my point of view as a project manager, if I don't have the certificated information security specialist, I will lose the project, and it's 40,000 euro. It's a 40,000 euro, yes. And for IT specialists, different observers, different observation, different evaluation of losses. And for information security specialists, if I don't have the certificate, I will lose the job which gives me 16,000 euro. And we just can say, we can see the different observations view on losses. It's always different, and we even didn't include in this counting assessment, we didn't include this correlation between them, this interaction between the customers, and etc. And the last one, interpretations of the causes of damage may differ between observers and can also change over time. It was a Petra ideas to have algorithm, but we cannot load you today. This almost holidays, so we will not load it with you, but the idea is that interpretations about losses can be used from to observers and from the different perspectives. So, for example, for our example, it can be for example, project manager if risk occurs. He can say that I didn't communicate risk correctly. I could not persuade customer to give me money for this certification. From customer's vision, he can say information security specialist can pay for his learning and getting certificate by himself, because it's his survival. It's his survival in the projects, in organizations, and his profession. And information security specialist also can say that PM didn't tell me how important it was for the project. I didn't realize the level of risks. So we have a very complex interrelated dimensions of meaning, and the first is fact dimensions, where we can measure data and losses. The next one is a time dimension. It's a dimension about decision now for the future. And social dimensions, relationship between stakeholders, PM, IT specialists, customers, and other roles in a project, because we understand that it's just a simple construction when we have just 3 person in project, but we have more, definitely. So it cannot be described in a simple way, definitely. So we need more and more understanding about this processing, and we started our research 2 years ago from description what are the main characteristics of social systems in information security. What should we know about this system, and the question, how can we use this knowledge while risk modeling processes. So there are interdisciplinarity, complexity, control fiction, dynamics, uncertainty, composition, and role of risk modeler. And I just want to ask Petra to continue and tell us about these parts. Thank you.
So thank you, Masha. If you want, you can go in the presentation mode. I don't know if this would be helpful. Change a PowerPoint in presentation mode, maybe. Yeah, we will see. To talk about interdisciplinarity, as Masha said, there are a lot of observers, and very often when there is a loss or a damage, afterwards we try to find the roots of it, like in root cause analysis. So there are a lot of different causes for a damage or a loss. So if you want to identify risk, it would be helpful to ask different disciplines, different specialists about that. For example, if there is a damage, you ask the internal audit department. It's always about controls. There's a lack of control, of course, if there is a damage. If you ask the CISO will say there wasn't enough money, and so on. So for risk identification, to get some kind of objectivity. In our theory, we don't believe in objectivity, but if you want to get some kind of objectivity, you take a lot of different perspectives together. And taking them, no, sorry.
Sorry.
Yes. And of course, there will be a conflicting interest. Yes, someone says it's enough to model the outsourced company just in one risk figure. Another person says, oh no, there are offsetting risks from our company to the outsourced company, so we have to model the outsourced company in detail. And all this has to be negotiated, and I think it also has to be documented as the assumptions in the model. So, thank you. We have here, we wanted to show the decisions that have to be taken, because we cannot, of course, we cannot show the reality of risk, so we have to make modeling decisions. The first important decision is how long is the forecast horizon. So as I say to my students, do you want to forecast the weather in 1 hour, or do you prefer to forecast the weather in 1 year? And of course, they want to forecast the weather of tomorrow. So the closer the damage, you have to forecast. So the easier, of course, and then the typical risk modeling decisions that I was confronted with are the conflicts of interest. Do I make a simple model which is understandable to all the stakeholders, which is understandable to senior management, which is which may be connected to them, or do we strive for completeness, which in fact is never reached? I had mainly this example of the reporting processes, because in banks and insurance companies we have a loss database, and there was a reporting for losses. And the problem was that small losses were not reported, which meant that, of course, you have on the loss distribution, there is a lack of small losses, which means you have truncated data, and then you don't know how much mass lies on the small losses. And if you don't know how much mass is on the small losses, of course, you don't know the probability of large losses. So another conflict of interest, which is well known in banks and insurance companies, is between stability and accuracy. So if you go back one step, sorry. Could you go back, Martha, please? So between stability and accuracy, people who work with the risk figures, they want a certain stability of the model, because they want to compare the situations over time. Does the risk rise or does it decrease or whatever, and want to compare risk to performance. And so they want the model to be stable. On the other hand, of course, the model has to be adapted to the risk landscape and to the situations. So you have to change it. Another decision that you have to take over time. Yes, thank you. Then we already pointed out that the Luhmann's theory has doubts about control. We don't think that a living system like a company and also the employees of the company can be controlled. We put security measures to control the company, but we don't know if they work in the end. So the environment changes, the system changes, and it's very difficult to put the right measures and to control risks. And this is reflected in the model, of course. Masha always told us about this. We already had an operational risk, the difficulty that if there was a damage, of course, then you changed the organization. You put in some security measures or controls, and then you didn't have the same risk situation anymore. So normally you have to put out the loss data for this kind of damage. In information security risk, this problem is even, or this challenge is even larger, because, as Masha put it, there's a cat and mouse game between attackers and defenders. So the attacker doesn't want to be discovered, and also the defender puts disinformation like honeypots, or tries to hide his vulnerabilities. So it's very difficult to see what kind of risk scenario is ahead, because the attacker tries to not to show it. Furthermore, we have uncertainty. In the traditional view, if there is a successful phishing attack, then it's the mistake of an employee who clicks on the annex of an email, on the attachment of an email. In social systems theory, we look at many causes. So, and we look on the organization. So we ask ourselves, I mean, the employee is not born with the wish to click on attachments of emails. It's not in his personality. But if there is a bad routine, like if there is a business process which is based on emails with attachments, then the probability is very, very high that one day you have this phishing attack. So, and there are several other reasons, technical reasons, like lack of network segmentation or no backup system, which all add up so that this phishing attack is successful. So it's the uncertainty of which kind of causes are relevant. By the way, just a remark, in the systemic idea is that no critical organization may fail because of the action of one single person. In safety, we are already there. In safety, we know that, for example, in a credit institution, you don't give one person the right to sign 1 billion credit. And we know that in nuclear power plants, that is not one person to push the red button and then it explodes. In safety, we know about that we have to implement routines and that several people have to be involved. And in information security, we are still on this idea. There is one person that is able to make a whole organization insolvent. But this is just a remark which is not much to do with risk modeling. So please, the next slide, Martha. So composition, we can see here on the right-hand side, there are so many dependencies, there are so many risk factors, as we said, and there are so many dependencies. On the right-hand side, we see dependencies, technical dependencies, which is in the physical security architecture, technical application architecture, and so on. This is only technical. We can also think of physical security if all the printers are in one room, all the important data is printed out there. So all the critical data is in one room, for example. And of course, we discover that the dependencies in normal days is very different than in catastrophic days. So in blue, you can see correlations on a normal day, and in the tail dependencies, I mean, maybe even correlations would be the wrong description, but anyway, there's a very close dependency. We have in our article the example of the flood in the Ahr Valley. There was a 7 meters high flood. Nothing worked anymore. Normal information and communication system works. People were dead. Animals were dead. There was a high pollution, oil spread everywhere. We had the risk of epidemics. We had the personnel, the employees in the official companies, the bureaucracy didn't work anymore because people were ill or saving their houses. So in catastrophe, everything breaks down. So next slide, please. So we discovered that this in the risk modeling process, starting from risk identification, risk modeling, and then risk communication, we have a variety of roles of security experts. We have people who have to think about interview techniques, for example, sociologists. We need experts to answer these interviews from different disciplines. We have the system analytics people and statisticians who have to model all this in statistics. And we finally have to use the results of the model. So we maybe are kind of teachers, or we have to explain the model to different stakeholders. And in practice, in my practice, I found out that scenarios support very well the communication and decision-making processes. So if you talk to senior management, for example, about phishing mails, then you have to show them that if the client order has to use the email, this routine is very probable to cause a damage, and it would be better to take different, like platforms or whatever, not to have this routine anymore and to cause more or less a damage. So these were the challenges going along with risk modeling. Hand over to Marsha.
Yeah, thank you. And on this picture, and Petra, thank you very much. You put our focus on organization and communication, decision making processes, and then we together always think how can we provide, if we cannot include every parameters, every characteristics and this complexity in modeling and in model, so how can we show it? And we can, but from the other side, we just cannot throw it away, because it makes our model weaker. So to make it stronger, to make it more successful, we need not only include these factors or some factors in the model, prediction model, but provide this infrastructure and these techniques for this communication, to provide this communication process and adapt the model adapt the model to provide its dynamic. So our proposition was raised very spontaneously when we did these user stories for another project, and I just thought about it for another project, and we thought that it can be a very good idea to implement these agile procedures for risk modeling teams, and to describe their ongoing communication processes. And by these procedures, as we can provide these three levels of reality construction for ongoing model change. These are observation, explanation, and evaluation and decisions levels. In observation level, the teams can take more information, more actual information about system state, and then try to understand is it can be dangerous, or it's a new threat, or what is this? Do we need to include it in a model? And then make decision. What should we do with the model result? Should we correct it, or we don't need any decision about it? So for this, as you can see on the slide, we provide some examples of user stories for different roles, and we can. Please, can you turn off your microphone?
Excuse me, dear colleagues, please switch off microphone.
Apa ya?
Orange campur dengan air ke?
Orange campur dengan ais kosong.
Excuse me, Ahmad, please switch off your microphone.
Tahu? Tahu tak? Sedap tak?
Mr. Ahmad, please switch off your microphone.
Oh, yeah. Thank you.
Excuse me, sorry.
Okay, thank you. It's normal. People have some time with children on Sunday, so it's good. User stories, as we can see, we can describe different role from different perspectives or different observers. We can describe as a user stories, and you can see here an example. What are the expectations of these roles? And I think that we propose it quite practical. Then how we can communicate it with customers. To have these tools, these tools we can describe in deliverables. So, for example, for risk manager, it will be necessary as a result to communicate with the people, with the team, with other departments, risk losses and scenarios report, because he wants to know the whole picture and etc. For CISO, for example, report of impact of new threats or new security measures on model and results. So the different kind of reports and different kind of deliverables for different roles for communication process. As I started my example, that I thought that I just my communication with customer was wrong, maybe, and I could not persuade him to pay for this specialist. So I need to understand in which template or which form I can present and I can communicate our results. And of course, we can use ceremonies to provide this communication continuously and in a regular base, and we can also, it's just a fragment. We provided more information in our article, and of course we wanted to show how it can include these characteristics that we have now in our presentation, and Petra presented. So how it can be included in different ceremonies. So if you will be interested in it, you can look at our article then. And as a conclusions, we need to say that when we look at the organization as a living system with unknown compositions that cannot be controlled, risk modeling is more complex, and risk modeling team has to handle interdisciplinarity, complexity, dynamics, and uncertainty, all these parameters. And it's even more complex because there is a trouble with inputs and informations, because two parts of interaction in information security processes try to hide it as much as possible, and instead of risk modelers integrating every kind of risk into the model, as we told, at any cost, they should incorporate the assumptions, limitations, and possible interpretations of the model into the communication process that can be provided by agile philosophy, agile procedure, and Scrum procedures, and other agile techniques. So the last picture, we didn't know where to put it. With Petra, we discussed it yesterday, and we decided to leave it here about questions, because, and so if you just can read this name of this picture, young man disturbed by flight a non-Euclidean fly. So we like this picture very much, and we I think that it can be vision of risk modeling for customers or another roles without any organization in cause. Thank you. Maybe Petra can add some conclusion.
No, thank you very much.
Thank you.
Thank you very much, Professor Petra, Professor Maria, for your very interesting presentation for challengeable topic. And now we have short time for question and discussion. Dear colleagues who will who would like, please, you can ask you by using chat or directly. Maybe I'll start. My question is maybe very is difficult as I think. But if we talk about engineering practice, we like to use any metrics, any values, and so on. You thought about very complex cyber social or cyber organization system, and about assessment risk for such system in general. My question is, which part, it's maybe your expert assessment, which part of this risk is a risk related to cyber security and information security? Because we understand that there are other kind of risks for such organizations, human risk, organization systems, and so on. Hence, could we
Підобрався? Сейчас, одну секунду, давайте.
Professor Zaslawski, please switch off your telephone, your mobile, your
I'm sorry.
sound. Sorry. It's my question about weight of cyber security, information security risks in general, risks of organization systems. Thank you. Maybe it is not question, maybe just remarks and suggestion for discussion.
Petra?
Petra?
No, I can't do as you want.
We think, and in social system theory things, that it is attribution. So what is the cause of a damage? Of course, maybe you first have a kind of cyber attack, but then it's the observer who says this damage is because this employee did not work as he should be. This is a very common explanation because it's cheap for the company. So people like it. I don't think that it's a useful explanation for the company, but it's a cheap one. Then you can also say it's that there are not enough technical measures. Then you can say the organizational routines are not structured in a way. So this is one of our main messages. So thank you very much for the question. It is attribution. It is an observer saying this is it. And systemic theory, systems theory, or the systemic profession that is based on systems theory says we should attribute a helpful explanation. What is helpful? It is not helpful to put the finger on an employee, but it is more helpful to say what should the organization do what if an employee makes a mistake or whatever, how make it resilient, I think is the modern word for it. So what should the organization, what can the organization do to be organized in a way so that cyber attacks doesn't kill me as an organization.
I also can add from my side, maybe as a question also was about what kind of risk can we include in cybersecurity risk models. Maybe I just can add that for cybersecurity for me it's all formalized procedure that you have in your routine. It's instructions, these are instructions and rules and organizational standards, international standards, and etc. So it can be included in modeling, but other perspectives, as Petra says, it's attribution, it's this implementation and communication, etc. So this is a procedure that can make this cybersecurity risk modeling more effective in organization procedures and organizations.
Thank you so much. Thank you. Any questions, colleagues? Okay, Professor Zaslavsky, welcome.
Yes, thank you very much for nice presentations. Really interesting, because I also involved in different projects with risk analysis, and would like to ask you about your approach for calculation risk, because organization with people is complex system, and people change system, also moderate new people, new specialists, but necessary also prepare and calculate some rank of risk. And if we see a small, will be found as a specialist and training and so on. And it's a different version, different value of risk. You use some technology. And you have, for example, redundancy, specialist. Because I cooperate with different company in Kiev, and people working together, and they found a new possibility to open new project, but they need specialists, you see, and necessarily moved some specialists from this project to second project and so on. And redundancy is elements in, for example, in technical system, it's new some double element, but specialist, it's also redundancy. Thank you.
Yes, we understand your question. Risk assessment and its risk assessment models, it was more Petra's specification for assessment. I mean, statistic, mathematician, and etc. Yes, I made evaluation of risk for projects. Yes, we have tools, and we have yes, of course.
Thank you very much.
Mm-hmm.
So the main models I saw is that you have a reporting system, and you set up a loss database with the losses that occurred of damages. Then it's also attribution. Is this a credit loss, or is this a cyber attack? Is this a cyber incident loss? And of course, because hopefully your company didn't have large losses, then you either have to take losses from other companies, or you have to do expert interviews who have scenarios who lead to large losses. So these are the three main sources for risk identification that I saw in a company. But I'm not sure if this is the answer to your question. Please continue to answer if we didn't get your answer, if we didn't get your question right.
Thank you very much.
Volodymyr, we also have, I also have a PhD student with adaptive fuzzy modeling for information security risks. So if you will be interested in this direction, he is finishing his PhD work and he has this real model.
Yes, it's very interesting to discuss about it. I call
Great.
you after.
Yes, thank you. Thank
Thank
you.
you. Yeah.
Yes, thank you. Good opportunity. Thank you very much for Vyacheslav Sergeyevich for your work.
Thank you. Okay, so thank you very much. Sorry we have not enough time for continue our discussion, and it's my pleasure to thank once more Professor Petra and Professor Maria for your very interesting presentation. I think it's in direction for interdisciplinary research because all system now with artificial intelligence, human issues, and so on. Hence, it is very important for us analyze risk of such organizations, such kind of cyber social systems. Thank you very much for your presentation, and hope for our new meetings and continuing of cooperation. Thank you.
Thanks a lot for your invitation. We were very grateful. Thank you very much.
Thank you very much.
Thank you. Thank you. Dear colleagues, we need to go ahead, and our next last streams of session 7174. Now we have short time for interruption and time for coffee break. I like to ask all moderators session 71, 72, 73, 74 to start according with time 11:15 and finish to 1 p.m. I like to invite all our participants to join very interesting final hour session. It's round table which will start at 2 p.m. In our next session, we have session 7.3 as reservation session, and we will show video of lost presentation at the session 7.2. Hence, please let's continue our sessions according to this program and these changes. Thank you very much for participating in this session, in this plenary talk. And let's start 5 minutes later. If you have any questions or maybe information from our moderators, please. No. Hence, let's meet 5 minutes later.